In the 1930s, the human mind itself inspired a man in the conception of both computing and artificial intelligence. For him, computation was the interplay between a child's mind and their workings out in an arithmetic book. Intelligence would be taught to the machine through education. Sadly, Alan Turing's life was cut short before his farthest reaching ideas were born out. But today, computers simulate worlds. Growing up in Manchester in the 90s, I saw video games develop. From Time Bandit on floppy disk to Halo on CD-ROM. I was catapulted inside the computer's imagination and inside Turing's imagination. And the steady beat of technology marched on. This chip can store more than 15,000 floppy disks, and it can process all that memory in parallel. If it's memory with the keys of a piano, it could play all the keys at the same time, creating impossible symphonies. I use it to train artificial neural networks, our best computational analog of the human brain. For the last 100 years, the galactic size and parallelism of the human brain put it firmly out of reach of computers. 100 billion neurons, roughly one neuron for every star in the Milky Way. AI pioneer Geoffrey Hinton called it the seething stuff underneath our consciousness. 100 trillion synapses. It's a sprawling web. At 4 bytes per synapse, that would take 400 terabytes just to store. Give every man, woman, and child in the United States a floppy disk, and you could just about store one human brain. So, the brain's pretty big. How big is a supercomputer? A supercomputer is built by daisy chaining these chips. The largest supercomputer in the world is in a warehouse in Tennessee, and they've hooked up more than 27,000 of these chips for a combined memory of 442 terabytes. It's 2019, and we've built a supercomputer that, in a very real sense, is more powerful than the human brain. Well, it's game over. Not so fast. We don't even know how to operate this thing. Can we teach a warehouse-sized neural network? What would it do? State-of-the-art neural nets are best at something akin to translation. They translate between languages. They translate between words and visual images. They translate between images and abstract concepts. Honestly, they translate between things they have no right to. All the evidence I've seen in my work suggests that bigger neural nets trained on more data solve harder problems. But if we want to train a warehouse-sized neural network, there's a problem. Some of the best training algorithms we have, like the one I used to generate this dog, explode once the neural network reaches a certain size. We don't understand why. These are the problems I want to solve to make the next leap forward in artificial intelligence. We've built supercomputers that rival the human brain in scale. Unlike the brain, we have perfect knowledge of their insides. Now is the time to realize Alan Turing's vision. I'm so excited that I get to play a part in that.